How do you know when you get a 30, 60, 90? How can you recognize it? And I'd say one situation that's kind of common is when you have an equilateral triangle. So I drew an equilateral triangle on the page here, and what happens is if you drop a height from the top there, from that 60 degrees, you get a 90 degrees there. So this angle is 90, this is 60. By default, in this triangle over here, that has to be 30 degrees. If that's 30, then that's 30 degrees. So all that height did was it split that 60 degrees at the top there in half. Alright, so that's one situation where you could end up with a 30, 60, 90. Okay? Let's look at an example to make sure you know how to solve for the sides in a 30, 60, 90 triangle. Okay, so we've got this 30, 60, 90 triangle here, and I'm telling you that this side length is 4. How are you going to solve it? Well, come test day, on your paper, really important, you're going to write 30, 60, 90. Under it, you're going to write x radical 3, 2x. This is a ratio of the sides. You got to have this memorized. So opposite 30 degrees, we have 4. Let's plug that in. So that means x equals 4. So opposite 60 will just be 4 radical 3. I'm just plugging in. 2 times 4 is 8. So let's put it in the sides. Opposite 90 will be 8. So the 8 goes there. Opposite 60 is 4 radical 3. That's 4 radical 3. And what does the problem want to know? What is the perimeter of the triangle? So we're just going to add up all the sides. 8 plus 4, 12 plus 4 radical 3. Not much we can do, with that expression after that. That's in simplest form. Okay, so this was kind of an easy one with the 30, 60, 90, but again, to get these right, you have to memorize the ratio of the sides. Okay, let's try another one. So for this example, let me straighten that out. Okay, we got a 30, 60, 90, but now we have a side length that's opposite the 60, and you'll see why this is a little harder in a second. So first thing you're going to do, come test day, you know you got a 30, 60, 90. You're going to write down the ratio of your sides. X radical 3, 2x. Okay, so from the problem, the 9 is opposite 60. So let's put that in there. I'm going to put it right under the 60. So am I saying that x is equal to 9? No, you can't get confused here. That's not what I'm saying. So what I'm saying is that x radical 3, this whole thing, is equal to 9. So let's write that on the side. X radical 3 equals 9. That's going to help us solve for x. I'm going to divide both sides by radical 3. Divide by radical 3. So x equals 9 over radical 3. You never want to leave a radical in the denominator. So we're going to rationalize. So we're multiplying the top and bottom by radical 3 over radical 3. And when we multiply across, we get 9 radical 3 over 3. 9 over 3 cancels out, and we just get x equals 3 radical 3. Okay, so now that I know that x equals 3 radical 3, we'll put that back in here. X, 3 rad 3. 2x, well, it's just going to be 2 times that, so 6 radical 3. Okay, so now I have my side lengths, I can pop them in. Opposite 30, 3 radical 3. Opposite 90, 6 radical 3. And what does this problem want to know? It wants to know, let's see, what did I ask? What is the area of the triangle? Okay, so I'm running out of space here again. It's going to get a little cramped, but let me see if I can fit the work in right over here. So what do we know is the area? Area is 1/2 base times height. So let's plug in what we know. 1/2, what's our base? 3 radical 3. Our height is 9. So we can do, when we multiply here, 3 radical 3 times 9 is just going to be 27 radical 3 times 1/2. And it came out kind of ugly right here, so I'm just going to leave it. I guess you could do it. We'll do 27 times 1/2 is 13.5 radical 3.